What is subquery? This is not specific to SQL Server. This is common to almost all the RDBMS software, Oracle, DB2. You take any RDBMS, the subquery is very commonly used one. What is the subquery is all about? A query inside another query. Okay, a query embedded in another query. We can say that way also. Okay. We'll first explore what is subquery and why subquery needs to be used, and where and how to use subquery, and difference between subquery and correlated subquery. And also we will take a look at the limitations of the subqueries. Okay. So a query embedded in another query is called your subquery. And what can we do with subquery? Why do we need to use subqueries? So there are some scenarios. We have to use the result of one query as part of another query. Okay. So, that will be, you can use subqueries in various parts of the SQL statement. In your select statement itself, you can use the subquery. In the from class, you can use the subquery, and where class, you can use subquery, and having classes also, you can use subqueries. Okay. Here there are some examples. Okay. These are the examples for when to use what kind of scenario and how to use the subqueries. So the scenario one, right? So you can use in select column from table 2. So this is your outer query. This one is called your outer query. 1 second. Okay, anything after in, this is your subquery. Okay, inner query. This is inner query. This is outer query. Remember this. And you can write you can use a subquery in your from class also. In this case, in the where class, we use the subquery. The from class also you can use the subquery, and even the join also you can use the subquery, and you can use the subquery in your select list itself. Column 1 instead of column 2, you can use this one also. Okay, and from table 1. So these are the scenario. This is how you can use the subquery from the from class, where class, and select class, and even the having classes. You can use the subqueries. Okay, so this is the one you need to be aware of it. For example, we want to check. So in this case, we have already created the employee and department table. Yes, what is that, Pradeep? Pradeep, yeah, we will first start with the simple one because I have non-IT people are there in this batch. Okay, we'll start with the employee and department, and I will give you some other demo database, how to install everything. You can, and also I'll give you some assignments. You can work on that. Okay, so that will help you to build your knowledge on the advanced part of the queries. Okay, first let us start with the basic stuff. Okay. For example, I wanted to find out the employees, whose department location is New York. How do I check that one? How do I check that? And what kind of query can I write it here? So the question here is, display all the employees, whose department location is some city. Okay, New York. I don't know what data I entered it here. New York. Okay, this is the query. Here we need to use double hyphen. It's not hash. Hash is for the Python. Okay, here double hyphen, you need to use it for the comment, single line comment. Okay, so what is the, how do I write a query here? Select star from. It's pretty simple, isn't it? Select all the employees. Okay, here they don't care about employee. I think we have employee table, not em table. Let me just check if this one works. No, here the demo database, we have the em table. Employee table is there, right? Okay, what I'll do is I'll just use the demo database. First, let us select the database. Use demo database. I'm going to select this database, and then I'm going to Whose location New York? Okay, it is not searched incorrectly. Okay. Here, let me just check if it is available now. Yes, it is available. First, you need to select the database. And the next one is you need to check whether the tables are available. Okay, before you fire your query, check all the tables that you use it in your query is available here. And then check whether these tables have data in it. Okay, data, everything is available. The next step is to answer to this query. So how do we write this and what logic can I use it here? Depart number. Okay, depart number. I'm going to use in operator here. Okay, select depart number from department table. From department table where location is equivalent to New York. And then I'm going to close this. Since this is a subquery, so I want to list down all the employees whose department location is. Okay, there is something wrong here in the department. Select star from depart. New York. It's case sensitive. Okay, here location. It is not. Look here. If anything wrong, if the column is wrongly, yeah. So depart number, location. Here location. Correct. Location. Here it is uppercase. Hence, make sure that you are using uppercase. Okay. So in this case, what is the inner query? This is your inner query. Okay. The other one is the outer query. This is your outer query. This is your inner query. Okay. We are driving the outer query based on the results of the inner query. Okay. In this case, this subquery returns more than one record. Okay. This subquery returns multiple records. If you see here, and okay, let me, yeah. So location is New York. Yes, correct. So here, this is the thing, right? We choose two different table here. Yeah, obviously, right? You can use, you're a quality person, testing, right? Testing people should be knowing SQL queries very well. In fact, testing people don't need this training at all. But anyhow, yes, obviously you can drive this table, right? In operator, location equal to New York. And in this case, this is how we can. So, but again, you freshers, right? If you don't have any programming background, don't panic. I don't think, upfront, you'll be able to learn everything over the night. Okay, what you do is you need to practice it over a period of time. You will get to know that, but keep practicing it. When it comes to software industry, you need to keep practice it. So, okay, this is one way of querying the data. In this case, is there any other way? Can I query the same? Is there any way can I produce the same output? Is there any way can I write the same query? Selection without using the subquery. Without using the subquery, can I do that? Can someone tell me? Employee and depart table D, right? So here E dot, both the table have the depart number. Okay, here what I'm going to do is, yeah, we will use the conventional way of writing it, D dot depart number. Here where and here D dot location is equivalent to New York. Where I just use go, and here also I'm going to put go here. First, let us see here. We have 5 records matching to the New York. Yes, 5 records are there. And here, both of them gives me the same output, right? Same output. In this case, I'm using the ename job salary depart number. And since I have used star here, all the columns from both the tables are displayed here in the output, okay? So if you don't need it, you can specify the column name explicitly here. For example, here you want to display only here E dot star comma D dot location alone. Okay, if you want the location alone, you can display that way also. So this is how you can use it. Okay. So E dot star all the columns from your employee table, and then the D dot location, only the location column from the department table. So D, so the E and D are your alias. Okay, it's a short name for your table. You can give the short name for it. Otherwise, what will happen? You need to type the entire table, employee dot star department. In this case, department is a smaller letter. Better you can use an alias, nickname. It's kind of a nickname, right? So use this. And E dot star is display all the columns for employee table, and D dot location I mentioned. If you want to specify only the specific column from the other table, you can see. So both the queries are producing the same output. Okay. So now, the next question is which query is optimal query? Okay. Which one is the best query? That we will discuss it later. Okay. So now you learn how to write a subquery, right? How to write a simple subquery here. And is there any other way we can write it here? For example, I want to see the here you can use a not in operator. It's not in. The other one is not in. Not in will give you except New York. Give me other location employees data. Okay, you can give this way also. In, not in, all these things that you can use it. And you can, okay, like I said, for example, you wanted to know whatever the salary, right? So okay, you want to find out the salary drawn by the employees. Let's say you want to see the average salary. You want to find out the average salary drawn by the employee. So how do you find it? It's a very simple. Look here, this is what I think we have discussed all, this one also, right? In the previous session. Look here, this is my average salary. Average salary drawn by the entire employees in my company. Now, you want to find out those employees are getting salary more than the average salary of the entire employees. So this is how we can use it here. So in this case, look here, I just take this one. This is another example for subquery, but in this case, this query is called as a scalar subquery. There are different types of subqueries. One is scalar subquery and other one is multi-row subquery. Okay. So in this case, if I select this and execute this one, this is the average for salary for the entire employee. So what I can do is I can substitute this value here. I can directly put it here. 1830. Those employees are getting more than this one, but this is called hard coding. You're not supposed to hard code the values here. This is not the best practice. Okay. So what we can is to make my query dynamic, try to make your queries as dynamic as possible. In this case, instead of putting this one, I'm just using this query itself, so that later point in time, if any new employees, any new records get included as part of this table, it will do the average on the entire data set once again, and then this one will get substituted here. So the output of this inner query, in this case, only one, right? Scalar value. So average salary is nothing but 1830. That is the one is returning now, as of now. If you insert additional records, this value will change. Okay. But this query returns a single value, hence it is called single scalar subquery. And this value is driving your outer query. So, okay, based on this one, the outer query is getting filtered. So here, what we see here, all the employees or those employees getting salary more than the average salary drawn by the entire employees in your company. So in your company, average salary drawn by the employees are 1830. You are getting more than that. So these are the guys, right? The 5 employees are getting more salary than them. Okay. And is there any other way? Can I rewrite this query? Is there any other way? Can I rewrite this query? You should be very good in rewriting your query also, because in the real world scenario, they will, if the performance is not up to the mark, you may have to rewrite the query, okay, to improve the query's performance. Here, I'm going to use some other technique. I just copy paste the same thing. E-name, comma, salary from employee. I just say employee as E. And here, the from class, I'm going to remove this now. So in the from class table 1, and then I'm going to use another, the inner query here. Sorry, the sub query. Select average of salary as, let's give some alias for this. Okay, average salary from employee as average salary, something like that. Okay, the output of this query available temporarily in this one. It's kind of a virtual table. Okay, this is kind of a virtual table, this subquery in this case. So previously I have used this subquery in the where class. Now I'm using the subquery in the from class. Okay. Where e dot salary is greater than avg sal dot avg underscore sal. Okay, go. Okay, will it work? Will it work here? See, you are a quality person, you should be knowing, right? If I give 2 alias, you mean to say you want me to give the same alias here? So this query output needs to be available separately, right? Right. This is, see, from class, I have used one table name, followed by that next table name I supposed to use it. In this case, my requirement is I don't have to use another table. Instead, I'm using the same table. I want to find out the average salary here itself. I'm storing that average salary here so that I can, in the outer query, I can use this temporarily stored value here to compare this. For this, we need to have this alias. Inner query, is that required? Oh, you mean to say this one? Is that what you're asking? Yeah. See, if you don't give this one, see, right? I just show you here. So I don't know if you noticed this one here. See, if you don't give the alias here, what will happen? In SQL query, what happens? It will not give you any column name, isn't it? Like a no column name. This is what we discussed in the very first session, right? So here it will not give any column name. Then how will you refer it here? For that purpose, one way it is good because I have a mix of most of them are non-IT people. One way that good that you ask this one. So here, if I don't use the alias here, what will happen is average cell, no column name will. So in that case, how will you refer it here, right? So the idea here is in the from class, I'm doing the average on this table, so and then I'm storing the output in a this one, the entire thing is kind of a virtual table, right? This is another table. Usually in the from class, we specify table A, comma, table B. Okay, but in the table A. So in this case, table is employee table. And then the second one is, so instead of using the table, I'm using the query. But this query returns only one value. For that, I know I'm going to use it as an alias. But like Pooja asked, right? So it's a good question, one way. So here, why you need alias here? The reason is, by default, it will not assign any column name when you perform any kind of aggregation, sum, average, minimum, maximum. Okay, got it? So hence you need to give this one so that, see, it's something like if I use e dot e name, e dot cell, right? Some average cell dot average cell, something like that. Okay. So you need to give alias here also, and you can give alias. So where clause, how to use the subquery, and in the from class, how we can. So now let us check this query, these two queries. And both of them returns 5 records. Both of them produce the same number of records. Okay. And now from the performance point of view, tell me which one is good. From the performance point of view, which one is good? So the first query is a non-correlated subquery. Okay. In this case, this inner query get executed only once. Please remember this. Only once. Okay. So in this case, the average will be calculated, and then this average will be used in their outer query to filter out the employees with the salaries above this average. Okay. The second query, what we are doing is, in this case, we are doing some kind of implicit cross join. Implicit cross join with a derived table. Okay. So this is kind of a derived table. In this table, we are deriving the average salary. So this kind of your derived table. Okay. So this derived table consists of single row, which contains the average salary. And then the filtering happens in the where class. And then the filtering is happening in the where class. Okay. Okay, so in this case, the first query is pretty straightforward. From the readability point of view also, it is really good. And also this one gets executed once. But here also, right, this one gets executed only once. But in this case, what is happening here? In this case, it's kind of the implicit cross join is happening. Okay. For every row in your employee table is matched with this single row containing the average salary. Every row in your employee table, for supposing you have 1 lakh employees, for every every row in the employee table matched with this single row containing the average. But whereas here, what happens? This query get executed only once. It gives me 1830. That 1830, so give me all the employees whose salary is greater than 1830. That's it. Whereas here, let's say I have let's say, in the case of TCS, right, 7 lakh or 6.5 lakh employees are there. For each and every employees, it goes and checks against this one, right? The average salary. So obviously this query's performance will be far better than this one. Okay. In case someone, if you find a query something like this, you can try rewriting something like this. Okay. Try rewriting something like this and see if and check the performance, how long it takes to query the data, how long it takes to query the data. And for that, you select these two queries and you will find something called the include execution plan. Include execution plan. Click on the, so you can you all see the icon, right? Include execution plan. Here's something called execution plan. That one gives you the, so now you click on the execution plan. One second, I just selected the, this. Include actual execution plan, include live query step. Both of them I selected. Now again, you select it and click on execute. Now only that one will get displayed here. like query statistics. You can see the query statistics here. Can you see something like this? So guys, you cannot see in the internet all the things. Okay, that's why I insist everyone to join the class, since still, most of them did not join here. Okay, so compute scale or clustered. So this is this one will give you the cost here, the query cost. The simple rule of thumb is execute both the queries. Whichever queries the cost is very high, then that query is not that good. Okay, the lesser the cost, that means better the query's performance. But it is not always true. There are some cases the cost may be very high, but the performance will be good. But in general, the general rule of thumb is higher the cost. What do you mean by cost here? The memory, CPU, and then the IO, right? How many number of IOs are required? So these are all considered as a cost. Okay. So more the cost, that means the performance is less, because it takes a lot of time to read the data from your hard disk, and then to perform the computation, it requires, yes, computation cost, right? Computation cost and memory, all the things. But in this case, both the query shows the cost is 50%. The reason is the data is very less. The volume of data is very less. That's the reason why it is not showing the correct picture. And like query statistics, and let's click on the execution plan. The execution plan, if you hover the cursor somewhere here, right? You can see somewhere here. Keep it here, and you can see it gives me a lot of the information: clustered index scan and row store, estimated operator IO cost, and the estimated CPU cost. In this case, the estimated CPU cost is 0001724. 0001724. Let us see. In this case, yeah, 003. Sorry, IO cost, and where is the CPU cost? CPU cost is, yeah, 0.0001724. 00. But with this, you cannot find out that much difference. Yeah, both the cases it shows the same thing, right? 0.01724. Yeah, so it's not much difference. Yeah, only with huge volume of data, you will find a significant, reduction in cost here, whereas it requires more. It's something like from your home. Execution plan is something like from your home. If you want to go to your office, okay, for if you want to go to your office, n number of routes are available. You use GPS, right? Whichever route is, listen, you find some shortcut. Right? With that shortcut, you can reach your office pretty faster. Hence, if you reach your office faster with this shortcut, you save the cost, right? The what is that? The petroleum or all the cost you will save. Time you will save, cost. So similarly here also the same analogy here. So it tries to find out the best accessible path in terms of fetching the data in a pretty fast manner. But with your query, if the performance is not good, if it takes longer time, you need to optimize it. Okay, in that case, you need to rewrite the query. So for example, this is your query, and after you have rewritten something like that, if the cost is very less with this, obviously the query, but here obviously, right, it does the computation only one time, and based on which it will filter this entire data. Whereas here, what happens? In this case, for each and every employee, because you've used the inner query in a from class, what happened for each and every value in your employee table, it goes and checks against this value, single row, right? It goes and checks each and everything. So it takes time. Okay. So obviously this is not the efficient way of writing it, but I just showed you for the sake of illustration purpose, how you can fine tune the query, how you can rewrite a query. But most of the cases, there are scenarios, right? You may have to rewrite the queries. Your query may not be optimal. You need to rewrite it. Okay. Okay. And the next question is, the next scenario is nested subquery. How can I use nested subquery? We will try the nested subquery. The same example, but slightly, let's the problem statement is find out the employees whose salary is more than the average salary of sales department. How will you write out? How will you find out? The same thing, select e-name up to this, fine, right? Anybody can write this one. Select the e-name. And then in the next one is from employee up to this, you need to tell which table, right? It's pretty simple up to this. And after this only you need to specify. Yeah, we'll discuss one by one. Pooja, made to start. See, the nested query is nested subquery. Nested subquery is, what do you mean by nested subquery? What is nested? A subquery inside a subquery. So what is subquery? Subquery is embedding a query in another query is called your subquery. But when you try to embed a subquery inside a subquery, that is called your nested subquery. Okay. I just write it here. What is nested subquery? A subquery this pretty straightforward, right? Subquery inside another subquery. Subquery was written with another subquery is called as a nested subquery. So this is the question now, right? Your manager is asking you, hey, write a query to find out the employees whose salary is more than. I want the report immediately. I don't know what query you are going to write. Give me the report. So how will you write it here? So from employee, okay, in this case, from employee and where clause, this is where we need to write the logic. Filtering condition, where we know the same thing, right? Where salary is greater than, select the same thing. From employee table, and here I'm going to say where, I don't know if the sales department is there here. Okay, let us give it a try. Okay, in this case, I'm going to, in this subquery, I'm going to use a where clause here. Okay. Depart number is equivalent to, and again I'm going to use another subquery. Select depart number from depart table. Depart table where, what is the question now? What is the question now? Department name is equal to sales, right? So D name is equal to sales. Will it work? So here for this one I have used this thing, and I need to put another parenthesis. Only then it will work. Select average salary from employee where department number. So can I query this one? Will this work? In this case, if I execute this one, waiting for query plan. Okay, you can need to go to the results 1590. It gives me the 1590, right? This is the average salary for the sales department. Here itself, I could have written a different way where department number. Okay, here I use the depart number. Or I could have used where depart name is equivalent to sales, right? See, this step is not at all required. Where D name equal to sales. Where D name equal to sales, isn't it? So in this case, but in this case, this is from one table, this is from another table, right? So hence you cannot write it that way. You cannot write it where D name equal to sales, because the department name is available in department table. This one is available, the average salary is available, in another table. Hence, this is the another way of writing your query. Okay. This query gives me the average salary for the sales department. This one will get executed once. In this two queries, what happens is, the entire query will get executed once. Okay. The output of this one will be used to drive the outer query. Okay. Now what? So look here, 1590. Can you all see it? This query's output is this one, the entire subqueries. So this is called your nested subquery. A subquery inside another subquery. This is what the parenthesis, right? In this parenthesis, use subquery. In this subquery, I'm used another subquery. Okay. Okay. Now what I do is I just execute this one. The keyword from employee select star from. Okay, what I'm going to do is I'm going to select star from. Okay, select star from. Here we don't need the alias because I'm not using any correlate subquery. From used to from twice. Where? No, there. Sorry, you are correct. Good catch. Thanks, Pooja. Here from I use it twice. Okay, that's the problem. Okay, and you can execute this query, and you can see the result here. So supposing you make any mistake like this, from you can see something like the underlined one. That means there is something wrong with the syntax. Okay, so sometimes what it will not strike. What you need, keep the cursor on top of this incorrect syntax near from. Okay, with that itself we can make out, and then you can remove it here. Now it gives me the output. You can see the query's output and how many records? 6 records. Fine. And can you see the department names? Look here, the depart number. What is the depart number for this? Sales. Is this doing correctly here? Yeah. Okay. Here. Yeah. Those employees' salaries greater than the average salary drawn by the sales department employees. Okay. So we have seen the average salary driven by it was something close, somewhat close to 1,4 something, right? 1,460, something like that. So obviously it is all more than that one. And beneath this, you can see the query here. Okay, nested loops. This is called your execution plan. Okay, and statement ID, node ID, and how it accesses the data, everything you can see it here. Then where clause and define everything, and execution is very difficult to interpret this one. But once you master this one, you can do anything in the SQL queries. Okay. Live query statistics. The cost is 100%. Okay. Okay. This is your nested sub. This is one of the examples for nested subquery. And also, what is the next one is multiple row subquery. So when can I use multiple row subquery? When can multiple row subquery? What is multiple row subquery? First of all, the subquery in this case, it returned only one value. Even in this case, it returned only one value. Even in this case, this is called scalar subquery. And there are scenarios, subquery has to, a subquery will return more than one record. So look here, this is the example. In this case, depart number, okay, here, even in this case, it returns only one value, right? The results, if you go to depart number 20, even in this case, it returns only one value, even in this case, okay? And okay, so this is called scalar subquery. Next one is the multi-row subquery. So what kind of scenario? The multi-row subquery will land up with having a multi-row subquery. Okay, for example, I want to find out okay, I want to display the same thing. Okay, nested subquery. Okay, here I just leave some gaps so that I don't have to search. Multi-row subquery. Let's say in this case, we want what kind of scenarios? Can someone tell me some scenarios with the simple thing here? Okay, we have some, yeah, in, right? We can use in operator. In operator can return more than one row. All, any. So we have something called, see, in, you can use in operator to return more than one row. And all, but in the previous case, the in operator was, returning only one value because we don't have many records existing for the New York location. Okay. And let's say, these are the operators that you can use it in the case of multi-row subquery. And for example, I have a scenario. I want to display the employees or display employees, those salary is higher than the salary of all the clerks. Salary of all the clerks. Yeah, we can use logical operator, correct. We can use, what do you mean by logical operator? Logical true or false, right? Yes, true or false is, you mean to, yeah, if the salary is greater than something, then it will return true. Otherwise, it will not return, right? It's false. Okay, fine. So in this case, the question is, I want to write a query. Could you display the employees whose or employees that earn a salary that is more than the salary of all the clerks. All the clerks, okay? Here what I'm going to do is, so the same query. Okay, here I just try select e-name, comma, job, comma, salary from my employee table, employee table, right? Yeah, employee table. Up to this, it is fine. Where salary is greater than all, I'm going to use the operator called all here, and then I'm going to use the select cell from employee. Here also, I'm going to employee, where you can also use nested subquery even in this case, where job equal to clerk. But in this case, I'm going to use the job, okay, not the department name, job equal to clerk. Is this correct syntax? Yes, it is correct. So what is all function does here? What is the all operator does here? It compares a value to all values in another result set. It compares all the values in a result set with another query, right? So that is what it does. So if you see here, select salary from employee where job equal to clerk, you can see multiple rows here. Results, if you go to results, look here, this many number of employees are there. Okay, 1058, 1300. So minimum is 1058, maximum is 1300. Okay. So now I just go and execute this one. Let's see what happens. No error. In this case, we can see that more than that, right? So minimum and maximum is more than that. So to display all employees that earn a salary that is more than the salary of all the clerks. Okay, all the clerks salary. Okay, more than the all the clerks salary. That is what this query gives us. So here, what is this all operator does here? The all operator compared a value to all values in another result set. Okay, so this it compared a value to all the values. It compared all the values in this query result set, but the outer query compared all the values of this query's result set. Okay, so that is what we are doing. This is one example, and next one is any operator. So in this case, let's say we want to find employees in a specific department. We want to find out the employees whose salary is greater than the salary of any employee in a specific department. Okay, any employee in a specific department. So how can we find out? Okay, before that, is there any way can I rewrite this query? Is there any way can I rewrite this query? That is a different thing. Okay, so you can give it a try, how to rewrite this query. Okay, and next one is how to use any. Here, what I'm going to do is I'm going to use the same thing. And here, instead of all, I'm going to use any here. And then here, okay, let us do one thing. Here, I just go and execute this one. In this case, it gives me 13 records. 13 records. And the previous case, it was giving me how many records? It was giving me 7 records. Okay. What is the difference between these two? First of all, yeah, you should be knowing what is any and all. I explained you. The all operator compares a value to all values in another result set, whereas the any operator compares a value to any of the values in another result set. Any of the values in another result set. Okay. So in this case, you want to find employees whose salary is greater than the salary of any employee in the specific department. Any employee in this specific department. Okay. It is slightly confusing, isn't it? 1 second. Sorry, I'm getting disturbed. 1 second, please.